Hello, welcome back to lesson number 5 in unit number 3, solving quadratic equations. This is the third unit in our grade 11 University College math course. So we're on the final lesson. Now we're embarking on word problems. We will only be looking at one type of word problem to finish up this unit, and they are, I guess, what you would call like rectangular, or I guess area questions involving rectangles. There's a little section here that just sort of details some of the things that you should consider when working through word problems. I'm not going to read that. You go ahead and read that. It's mostly just stuff about good form. Let's move right on to example number 1. So example number 1 says a rectangular pool measures 10 meters by 5 meters. A deck of uniform width is to be built all the way around the pool such that the total area of the pool and deck will be 126 meters squared. Set up and solve a quadratic equation to determine the width of the deck. So starting with a couple of let statements, I let A represent the area of the pool and deck in meters squared. And that's important. What I'm setting up here is the total area of pool and the uniform deck around the outside, sort of like the larger rectangle rather than the smaller one on the inside. And then letting X represent the width of the deck. All of the problems I would say that we're going to tackle, word problems we're going to tackle in this unit are going to be similar to this, where you've got a uniform border around the outside. So how do we tackle this? I think we'll start by looking at this drawing that I've made here, and we're going to add a couple of notations to it that I hope will help you understand how this question comes together like a quadratic. So if we were going to calculate the area of this whole rectangle, I mean not just the pool, but the pool and the deck combined, we would do the length times the width. But right out of the gate, we aren't told exactly what the length is. However, if we look at that side, we'll notice that the side of the pool is 10, and that because this is a uniform border around the outside, you have a width up here and a width down here. So if you were to combine those things, it would make the length of this particular shape 10 plus 2x's. We're going to employ that same thinking here at the bottom side, where again, we've got a width all the way across the pool of 5, and then we've got these two x's kind of hanging out here. X's because, again, it's a uniform deck around the outside. It's going to have the same width on both sides. So if we were going to combine all of the terms on this side and add them up, that would give us a 5 plus 2 x's. So this way of figuring out what the length and width of our rectangle is going to be something that we're going to be doing every time we work a problem like this. So now we get to the math. The math, pretty straightforward. We know that the area of a rectangle is the length times the width. In this case, in this question, we've been told that the area is 126 meters squared. That's the combined area of the pool and the deck. The length we've just calculated as being 10 plus 2 x's, and the width we've just calculated as being 5 and 2 x's. From here, if we're trying to solve this, and again, once we expand this out and get it into a standard form quadratic equation, we're going to see that this is a quadratic. To solve this, we need to put it into standard form so we can decide whether or not to factor or use the quadratic formula. So let's do a little bit of expanding here. We've got our 126, and now we're going to just expand these two binomials out, just like we did way back in Unit 0. Expanding these guys out gives us 50 plus 20x's plus 10x's plus 4x squared. So in this next step, I'm going to combine all of my like terms, and I'm going to transpose 126 over to the other side of the equation by subtracting 126 from both sides of the equation. So that's going to give us 0 equals 4x squared. I'm just writing these terms in order of degree so it looks a little more familiar to us, like a quadratic equation in standard form, plus 30 x's. And now we have our 50 minus our 126, and that gives us negative 76. So there we go. We have a representation of the area of this shape. We now need to solve for x. The solution to this will tell us the width of the border around the outside of this shape. I'm going to try, as I would recommend you do, to factor these anytime that you can. So I'm going to start by common factoring a 2 out of this equation. So we've got 2x squared plus 15x minus 38. So now I've common factored it out, and I have a tricky trinomial still here to tackle, which I will underline. So this tricky trinomial is right here. I'm going to try to factor this, and I'll just sort of scooch off to the side to do it. As we recall, we're looking for the thing that multiplies to negative 76. Again, that's the product of our, I'll change that to green, the product of our A and C values, and which adds to our B value, in this case, positive 15. So I'm going to look for factors that will work. There are 2 factors that will work for us, and those factors are going to be positive 19 and negative 4. Hopefully you have your factor sheets with you. If you don't, obviously you can just use your calculator. Looking at a number like 76, it's divisible by 2. You might divide it by 2 to see if those 2 numbers work. Then I went and I divided by 4 because I don't have my factor sheet here with me. Found that it paired with 19 and that those 2 numbers combined will give me a positive 15. So now if we're going to decompose, we've got our 2x squared, there's our negative 38, and what we're doing is we're breaking this middle value down into the 2 values that led to it. So plus 19x and minus 4x's. And now we're going to factor by grouping. We're going to factor these first 2 terms by grouping, followed by the second 2 terms by grouping. So we have, just to keep rewriting it, the greatest common factor in 2x squared plus 19x is going to be x. And when I factor that out, I'm left with 2x plus 19. And then I'm going to common factor negative 4x minus 38. The greatest common factor is negative 2. And when I common factor that out, I'm left with 2x plus 19. And now we're going to find the greatest common factor in our 2 remaining terms. So the greatest common factor will be 2x plus 19. And when we factor that out, what remains is x minus 2. So we have factored this. It's not solved yet, it's just been factored. The way that we solve it is we set each of these factors equal to 0. So there's our first one, there's our second one. Now the goal here is to, I should set that first one equal to 0 as well. There we go. We are going to reorganize these to isolate our variable x. So I'm going to bring 19 over to the other side by subtracting 19 on both sides. Then I'm going to divide both sides by 2, giving me negative 19 halves. First one's a little more straightforward. I'm going to isolate x by adding 2 to both sides, which gives me x equal to 2. So here are 2 solutions. What I'd like you to consider, though, is this is a real-world problem. This is a real pool, a real deck. One of these answers isn't going to be an answer that we could ever use. This answer in particular is the one I'm talking about, and the word that we would use to describe this for this question is inadmissible. That's just sort of a fancy way of saying you can't have negative 19 halves as the length of a pool, or the width of a pool deck in the real world, which means that then our actual correct answer is the other, x equals 2. So because this is a word problem, we're going to pop a little therefore statement over here. So we would say, therefore, the width of the deck is 2 meters. And there we go. That is our first word problem. Now this video is already closing in on 10 minutes, so what I'm going to do is trying to keep all the videos around the 10-minute mark. What I'm going to do is just stop this video now, and I'll do the second example in another video, and then I'll do the third example in another video if they take that long. And then we should be good. So hopefully this helps. Good luck, and if you need it, I'll see you in the next part of this video.